Alright, so today we're going to be talking about electron domain geometry and how that influences your molecular geometry. So we've talked about electron domain geometry. Our three main types are linear, our trigonal planar, and our tetrahedral shapes. Those basic electron domains are going to help influence our molecular geometry. For linear, it's the same molecular geometry and electron domain geometry. What your molecular geometry is going to do is it's looking at the shape of the molecules. So you're looking for the shape of the molecules here, not the shape of the electron domains. Okay, so electron domains is going to be showing you what's happening to the electrons only. All right. Our trigonal planar are going to be the same, but there's going to be a second option. So when we have three electron domains, and not all of them are bonded. Two of them are bonded, but one is unbonded. It's a lone pair. That's going to be bent. So these two right here are going to be your trigonal planar domains for electron domains. But this one right here, it's going to show a bent molecule. We'll go a little bit more in depth in this in a few minutes. Okay. For tetrahedral, we have 4 electron domains. Okay. And if one of them is unbonded, you have one lone pair. It's going to be trigonal planar. Right here you can see, sorry, trigonal pyramidal. And you can see right here, it looks like a pyramid. 1, 2, 3, 4. Like a pyramid. Okay, trigonal pyramidal. And then the last one is going to be tetrahedral bent. Okay, so it's going to be bent, but it's going to be tetrahedral. So these are the names right here of your tetrahedral electron domains. Okay, so let's go a little bit more in depth into that. Alright, so we're talking about VSEPR. VSEPR is the valence shell electron pair repulsion theory. So valence shell, talking about our outside shell, electron pair, the electron pairs in the outside shell, and repulsion is going to be talking about how the electrons repel each other. When you have two negative charges, right, they push away from each other. Opposites attract, the same thing will repel. All right? So basically what this is, it's a theory and it's a model for predicting molecular structures and their shape. Okay? The structure around each atom is determined by minimizing repulsion. So basically the electron pairs are going to be as far apart as possible. So if you have a center atom and you've got 3 electron pairs, they're going to push themselves up away from each other as far as possible, just like this one, okay, where you have 120 degrees between each of them. All right, they're going to push far apart. All right, and basically what you're going to be doing with this is you're going to determine the name of the molecular structure. You're going to determine the name of the geometry based on its atoms. So what I've got here is I've got 2 balloons, which I've put together. And this is going to be showing how 2 balloons are going to push away from each other, just like 2 pairs of electrons would. Okay, so that's your linear geometry. And you've got your central atom right here in the center, okay, where I'm holding. And we've got 3, and they're pushing as far away from each other as possible. It ends up in a trigonal planar shape. Okay, so that's 1, 2, 3. And you'll notice it's in one plane. So it's not 3D, it's in one plane. So it's trigonal planar. The fourth one is tetrahedral. So there are 4, 1, 2, 3, 4 geometry. Okay, 4 domains, and they're going to push apart as far as possible. That means that it has to go into 3D. It's not in one plane, right? If I do this, it's not in one plane. It's actually 3D. Okay, so these are a nice little representation to help you. Okay, so first one is linear. It's going to have the linear geometry just like this, but it's also going to have linear shape when you look at it as the molecules. Okay, so when you look at those molecules, and you'll notice that there's going to be a bond angle from this atom to this atom of 180 degrees. Okay, it's linear. Its electron domain is linear, and its geometry is called linear. The next one is trigonal planar, which is going to be 3 electron domains, just like this one. Okay, and between the atoms, you're going to have 120 degrees as your bond angle. You can figure that out because 360 is a circle, right, and divide it into 3 sections, it'll be 120 degrees each. So if all 3 electron domains are bonded to an atom, it's going to still be called trigonal planar. We're going to look at a case next where one of them is not bonded to an atom. All right, so in this case, we still have a trigonal planar geometry. Okay, so it's a trigonal planar electron domain. Okay, because we've got 3 domains. But right here, I didn't draw it in, but pretend that there's electrons here. They're still pushing those atoms away, so that's why you still have the same bond angle, but there's no atom there. Okay, so we look at just the shape of the atom from here to here to here is called bent. So the shape of the atom based on the molecules is called bent. Okay, so we're going to call this, again, a 120 degree bond angle. And same thing, from this pair of electrons to this atom is still 120 degrees. So that's bent. Our next electron domain is our tetrahedral. So tetrahedral looks like this. Remember, we don't have simulations all the time with our pen. We use the line and wedge diagram. So if these two are in plane with the board, this is wedging out, and this is the lines, dashes going back. So if all 4 domains are bonded, this is what it's going to look like. Okay, this one is going to be one lone domain off of a tetrahedral shape. So if you look in the corner here, you can see this yellow dot right here. Think of that as your lone pair. Okay, so it affects the shape because it pushes these atoms away, but you aren't looking at it for the name of the geometry for the molecule. So you have 1, 2, 3. These are your lone pair of electrons. It's called trigonal pyramidal. All right, the bond angles for this one are going to be 109.5. And that's the same for tetrahedral, 109.5 degrees. The next one, also tetrahedral. So look at your basic tetrahedral shape. So you've got your line, your wedge, your dash, okay, your 4 items, except 2 of them are going to be lone pairs. So these 2 are both lone pairs, but your wedge and your dash maybe, okay, are still there. So there's still this angle right here between these 2. This is what we call tetrahedral bent. And it looks similar to the other one, except this is a 109.5 degree angle. Okay, 109.5 degree angle. Remember, this is a lone pair of electrons, this is a lone pair of electrons. So they push these 2 atoms away from each other, so you still have the bond angle. However, the molecule shape, when we're just taking into account the molecules, not all the electron domains, is called tetrahedral